Hi everyone, Geotechnical Engineering Part A Soil Mechanics, Lateral Earth Pressure at Rest Rankine and Coulomb Theory. In this example, we have a cantilever retaining wall as you can see in the figure handling a backfill soil with the angle of 15 degrees with a slope of 15 degrees at the top. The height of our wall is a 30 feet. The soil is a sandy soil with the angle of friction of 30 degrees and unit weight of 120 pound per feet cube. And we want to calculate the active force which applies to this retaining wall due to backfill soil. So the formula for that is a half of Ka gamma h square, and also the wall itself is extended like 20 feet 25 feet in length, so it just extended the z direction. We want to calculate the horizontal component of the total active earth pressure resultant force acting on the wall. So let's see how we can approach this problem. So in calculation of active pressure, we can solve this problem with three different approaches. The first one is Coulomb earth pressure theory. The other one is Rankine's pressure, and the last one is the easiest one, which is Rankine's pressure. The same like approach too, but you're just need to read the coefficient from the table. So that's the easiest approach, just replacing the coefficient and get the answer. We'll move step by step to solve the problem with all these three methods. The active earth pressure FAF active is a half of KH, and because of our problem we want the horizontal component of that force, so FA like horizontal is equal to the same concept if you calculate it for KAH, and then gamma times H squared. So the first approach is the Coulomb earth pressure solution 1. The formula is this one. We need to first calculate the unknown Ka, then replace in the formula to get the Fa. So in Coulomb theory, which is the solution 1 approach, we have these parts. So we do have a wall, there is a beta here, there is a theta here, there is a delta, and if you then you can easily calculate K active by this equation. So this is our problem. So you can easily replace, you can easily see this is our beta. So it just simply says our beta is equal to 15 degrees. And let's see what are the names. This beta is angle of backfill pressure. Backfill a slope like what we have here, like alpha, and then theta is the angle of backfill, angle of wall space. Wall slope, which in our case theta is equal to 0 because it's like a horizontal one, so there is no angle here. It's theta is equal to 0. If there is some kind of tilted angle there, and then delta here is equal to a friction between friction between wall and uh, soil. So again, in our case, delta is not provided, so that you can consider that one as 0 too. So as soon as you have all of them, so we just have like a theta and a, like this one goes to 0, phi is provided to be 30, delta is 0, theta is 0, theta is 0, and just cosine of theta is 1. So there's nothing wrong with that. And we just have like beta is equal to our alpha in our problem, which is 15 degrees. Don't worry about the terms, just replace your angle in the Coulomb's equation angle. So we just have a phi and beta in our problem. So if that's the case, we can easily calculate our Ka coefficient. So if you replace the zeros, then theta is equal to 30 degrees, phi is equal to 30 degrees, and beta is equal to 15, which is this one. And if you replace that in Ka formula, it just gives you a Ka active coefficient, active pressure coefficient is 0.4019. So that's almost 4. And we need to consider the horizontal component of that. So if this is like FA and apply to the solid by this angle, like 15 degrees. So this is FA, and we need to have it like uh, horizontal component of that. So that gives us FA if our KA is zero point 0.4, KA horizontal is just KA cosine 15. And so if this one is 0.40, it just you just multiply it by cosine of 50, it just give you 0.386, and that's our KAH. As soon as you have that, the rest is simple. You have gamma from the problem statement, you have height of wall, square it times half of that, like the equation, and it just gives you this amount of force. And if you multiply that by the length of your cantilever retaining wall, it just gives you 500, almost 521 kilo pounds of forces in the horizontal direction. That was our solution 1. Let's move to solution 2, which is the Rankine theory. So Ka of Rankine is equal to this equation, cosine of alpha, and you can find these equations both in uh, geotechnical engineering textbook, like in uh, any foundation books, and also FE and PE manual, reference manual. So don't worry about it. You just need to move to the section of a like active and passive pressure and find this kind of formula. And this is a kind of similar equation, but just with different terminology. So this is a positive alpha, this is negative alpha. So don't worry about if they are alpha or beta, just look at your shape and pick the right angle for that. So R is a positive alpha, and definitely we don't have any theta because there is no the horizontal sway of our uh, uh, wall there. So in that term, if we can have our rank in an active force like FA and replace in our equation, so we have like 15 degrees for our alpha and phi prime is 30 degree. Replace that, it just gives you a Ka, which is very similar to Ka of Coulomb in Rankine theory, but it's like that time it was zero point 0.4, and now we can have like 0.373, which is almost very close to the previous approach. But in terms of having the horizontal component of that, so you have to multiply it by cosine of 15 degrees, so it's just 0.36, and then Fa is equal to this amount, and if you multiply it by the length of the wall, it just gives you 486 skips. Mhm. And the last one is the ranking theory, but this time we will read our Ka from a table provided in the textbook, so or reference book. So we do know our alpha is 15 degrees, so just move to alpha like 15 degrees. So this is our alpha, which is here. We have it like 15 degrees. Then move to theta, which is the tilted of the valve, which is, in our case, that's 0. So let's move to that one. So if alpha is 15, theta is 0, and also we have also our phi, which is the friction, like 30 degrees. In that case, we have a coefficient of 0.373, exactly like what we calculated from the formula for Rankine. So again, if we have that one, horizontal component of that would be 36.36, and if you do that and then multiply it, it just gives you the same numeric value. And if we want to compare the solution 1 through 3, it just gives us Coulomb, Rankine, Rankine. And the third one is Rankine from the table, and Fa is definitely a half of Ka gamma h squared. The first one gives us a Ka equal to zero point 0.4. The second one, 0.373. And the last one, the same, because this is the same method, but different approach. And if we calculate the Fa, it just gives us the numeric value of 486 skips for the first and last method, because they are the same method but different approach. And the Coulomb one is the Coulomb one, it should be gives us the numeric value. So this is my bad, this is 521.11, and this should be 486, because this is Rankine theory, this is Rankine theory, but different approach. So it should give you the same numeric value. So 486, and the very first one is 521. Thank you. We'll solve more problems on